Hello students, this is Santosh from Parth Tank Mathematics Institute, Ahmedabad. You know, NTA is publishing IIT, JEE, mains and NEET level question papers, and Parth Tank Institute is presenting to you the solutions of the mathematics part of these question papers. In this video, I'll take you through the solutions of the mathematics part of NTA test paper 01. So here we begin. The first question. If the roots of the equation ax squared plus bx plus c is equal to 0 are in the ratio m is to n, then which of the following conditions is true? Okay, all the questions that are based on these properties of the roots, you know, the first step is always to write the sum of the roots and the product of the roots. For a general quadratic equation of this form, ax squared plus bx plus c is equal to 0, you know that if alpha and beta are the roots, alpha plus beta is minus b by a, and alpha beta is c by a. They have also given us that alpha is to beta is in the ratio m is to n. Therefore, we can write alpha as m into some k and beta as some n into k. Substitute both of these in these equations. What would you get? The first thing is mk plus nk will be minus b by a, or this would give us k times m plus n is minus b by a. Then in the second equation, mk into nk is c by a. Now this would give us mn into k squared is c by a. Let's call this 1 and let's call this 2. If you eliminate k from 1 and 2, we have the required relationship between mn, a, b and c. How can we do that? Square 1 and divide it by 2. So 1 square upon 2. 1 square is k square into m plus n the whole square. And here we have minus b by a the whole square upon k square into mn upon c by a. Now k square is gone. M plus n the whole square by mn is equal to b squared by a square into a by c. This would give b squared by ac. Therefore, you can simplify this to get b squared into mn is ac into m plus n the whole square. Therefore, the answer is option A, b squared into mn is equal to ac into m plus n the whole square. A very simple problem, direct substitution in the properties of the roots. Let's move on to question number 2. The domain of definition of the function y given by 3e to the power square root of x squared minus 1 log of x minus 1 is. Now this is another very direct question. All we have to find is the domain of definition of these two functions, square root of x minus 1 and log of x minus 1. Now square root of x squared minus 1 needs that this argument should be strictly 0 or greater than 0. That is, x squared minus 1 should be greater than or equal to 0. Now this means x minus 1 into x plus 1 should be greater than or equal to 0, and therefore x should be greater than 1 or x should be less than minus 1. Because you know, when a quadratic equation has roots, this equation as a quadratic equation would have roots x is equal to 1 and x is minus 1. And when it is an inequality, if the inequality is greater than, it means the region outside the roots, and if the inequality is less than, then the region is between the roots, right? So here the solution is the region outside the roots, including 1 and minus 1, of course. Therefore, you can write that x should belong to open interval minus infinity to minus 1 included and 1 to infinity excluded. Alright? Let us consider log of x minus 1. Now log function cannot take a 0 or a negative argument. Therefore x minus 1 has to be strictly greater than 0. Therefore x should be in the interval 1 to infinity. When you consider x should be common to both these intervals, it is easy to say that x should be in the interval 1 to infinity, both 1 and infinity excluded, right? The common part is only the open interval 1 to infinity. Therefore the solution is option A, open interval 1 to infinity. A very direct question indeed. Moving on to question number 3. It is a definite integral based on the greatest integer function. The value of the function minus 1 to 1 integral x minus greatest integer function x dx is. Okay. Now you can do this directly or by remembering how the integral of box function looks like also. Okay, first of all let us try it directly. Now this function integral minus 1 to 1 x minus box x dx. First of all, let us split it into two integrals. Minus 1 to 1 x dx minus of minus 1 to 1 box x dx. Now this first integral, if you see, x is an odd function. Any odd function integrated from minus 1 to 1 is 0. Therefore this integral is 0. So it is gone. So the second integral is nothing but minus 1 to 1 with a negative sign box x dx. Now let us split this into two parts. From minus 1 to 1, keeping the minus common out, box of minus 1 to 0 box of x dx, and 0 to 1 box of x dx, because we know the box function changes value at each integer location. Alright. So now this becomes, in this region x between minus 1 to 0, box of x has value minus 1. And in this region 0 to 1, box x has value 0. So again this integral is 0 because box of x is minus 1 in this region and box of x is 0 in this region. Therefore this integral is simply integral dx from minus 1 to 0, which is x from minus 1 to 0, or 0 minus minus 1, which is plus 1. Therefore the answer here is plus 1, option B. Now this can also be done quickly if you remember that x minus box x represents the fractional part, right? Fractional part of the number x. Therefore, how does the graph of this function look like? It take x is equal to 0. From there to 1, this function keeps increasing, and at 1 it becomes 1 minus 1, 0. And then again the fractional part, it keeps increasing, and at 2 it again becomes 0. And then again from here it keeps increasing, and at 3 it becomes 0. The same way with negative integers also, minus 1. So this is the function x minus box x. If you remember this graph, then you know that in between two consecutive integers, x minus box x looks like a right angle triangle whose length is 1 and height is also 1. Therefore the area of each triangle is half into 1 into 1. Therefore it's half. So using this idea also you can say that integral minus 1 to 1 x minus box x dx is nothing but 2 times such area, two triangles, two right angle triangles of this area. So it is 2 into 1 by 2, which is 1. The same answer as we got from the direct method. Let us move on to question number 4. This is a problem based on the heights and distances and some trigonometric equations. The question says, a flag staff of 5 meters high stands on a building of 25 meters height. So let's draw this as we are doing. Let us say this is a building of 25 meters high, and on the top of it there is a flag staff which is 5 meters high. For an observer at a height of 30 meters, let us say there is this observer who is standing at another adjacent building which is also 30 meters. So imagine he is at the same level as the top of the flagstaff. The flagstaff and the building subtend equal angles. Alright. So the flagstaff is, let us say, subtending an angle alpha. They've also given us that this building also subtends the same angle alpha to the observer. The distance of the observer from the top of the flagstaff, this distance is how much? Alright, this is a very simple question. Let us name the triangles for convenience. We know in triangle ABC, tan alpha is 5 upon x. Same way, in triangle ABD, tan alpha would be 30 upon x, right? I'm sorry, tan 2 alpha, because the angle here is 2 alpha. Now you get the value of x if you manage to eliminate alpha between these two equations, which is very simple if you substitute the formula for tan 2 alpha in this equation. Now we know tan 2 alpha is nothing but 2 times tan alpha by 1 minus tan squared alpha. Now this is equal to 30 by x. All that is left for us is to substitute this equation 1 here. If you substitute equation 1, that is tan alpha is 5 by x, let us see what happens. We get 2 into 5 by x by 1 minus 5 by x into 5 by x is 30 by x, or 10 by x, and the denominator I get x squared minus 25 by x squared is 30 upon x. Now these two sides can be cancelled to have only 3, and a bit of rearranging gives x squared is 3x squared minus 75, or 75 is 2x squared. Therefore x squared is 75 by 2. I am writing this as 25 times 3 by 2, so that x can be obtained on taking a square root as 5 into square root of 3 by 2 meters. So the answer is x is 5 into square root of 3 by 2 meters, which is option B. 5 into square root of 3 upon 2 meters. Let us move on to question number 5. This is also a very simple problem based on the domain of dependence for the functions. If R is the relation between x and y such that x is related to y, both are integers, x and y both are integers, and the condition between x and y is x squared plus y squared should be less than or equal to 4. Now the domain of R is the admissible values of x, right? Now x, since it is an integer, it belongs to 0, 1, 2, 3, 4, minus 1, minus 2, minus 3 and so on. However, this condition x squared plus y squared is less than or equal to 4 stipulates that this y squared can be a minimum of 0. Therefore, x squared should be less than or equal to 4. Therefore, x should be less than or equal to 2, and it should be greater than or equal to minus 2. That is, it can take only values in this region, right? Very simple question. Option C, minus 2, minus 1, 0, 1 and 2. No complications at all. Very simple logic. Moving on to question number 6. Now this is a very interesting question. It is asked, what is the remainder when 5 to the power 97 is divided by 52? Now you will know by this time that all such problems are based on binomial theorem, because binomial theorem helps us identify very high powers and to get meaningful expressions for those. So your logic in this problem should be, how can we connect some power of 5 and 52? Okay. Now 5 to the power 1 is 5, so no point. 5 square is 25. 5 cube is 125. All these 125 can be written as 52 into 2 plus 21. Now, not much use, but 5 to the power 4, which is 625, is interestingly 52 into 12 plus 1. This kind of thing, something plus 1, is always very useful in binomial theorem, right? So, what we have is 5 to the power 4 is 52 times some k plus 1. It is a multiple of 52 plus 1. That is the meaning of this side, right hand side. Okay. How can we do 5 to the power 97 with this? We know 5 to the power 97 is 5 to the power 96 into 5, and 5 to the power 96 is 5 raised to 4, the whole raised to 24, right? So raise the whole thing to 24 and multiply it by 5. Okay. So 5 power 4 raised to 24 will be 52k plus 1 raised to 24, right? And you know from binomial theorem, this expression should be 24c0, 52k power 24, then plus into 1 power 0 basically, and then 24c1, 52k power 23 into 1 to the power 1. This is the advantage of having 1 in the binomial expansion, because this 1 doesn't matter at all. Likewise, you can write till the last term, the last but one term would be 24c23, 52k to the power 1 and 1 to the power 23, which you don't write, and then 24c24, 52k to the power 0. Alright, so 52k to the power 24, 52k to the power 23, going on decreasing till 52k to the power 1 and 52k to the power 0. Alright, now you see all these terms, the first, second, are all multiples of 52, because they are 52 to the power 24, 52 to the power 23 till 52 here. So all of these terms from the first term till the last but one term, we can say is another multiple of 52. Let us call it 52 times capital M plus 24c24 is just 1, right? So you see what we have got? We've got 5 to the power 96 is also 52m plus 1. Okay? Alright. So let us go from here. We have 5 to the power 96 is 52, a multiple of 52 plus 1. Therefore 5 to the power 97 would be 52m into 5 plus 5. Therefore, when you divide this by 52, the first term is divisible by 52, but 5 is not, and therefore 5 is the remainder. Right? Let's go through the solution once very quickly. We identify first that 5 to the power 4, which is 625, is 52 into 12 plus 1. That is 52, a multiple of 52 plus 1. Using that, we get 5 to the power 96 by binomial theorem, and we show that all the terms are multiples of 52 except the last term, which is 1. So again it is 52 into an integer plus 1. 5 raised to 97 is that multiplied by 5. So I get a multiple of 52 plus 5. So when this is divided by 52, the first term is divisible by 52 and the second term remains. So the remainder is 5. Moving on to question number 7. Y is equal to 4 minus 5 is a tangent to the curve y square is equal to px cube plus q at 2, 3. Then the values of p and q are. Now to find two unknowns, we need two equations. So the one equation is that this point 2, 3 lies on this line, on this curve, right? That is 2, 3 lies on y square is px cube plus q. Substituting here, you get 8p plus q is 3 squared 9. Let us call this equation 1. Now the second equation would be that y is 4x minus 5 is tangent to the curve at 2, 3. So the slope of the line y is equal to 4x minus 5, and the slope is easily 4, because you know that the standard form is y is mx plus c, where m is the slope and c is the y-intercept. Yes. So slope is 4. Now if you find dy by dx of that curve at 2, 3, that should also be equal to 4. So this will give us the second equation. How to find dy by dx? Differentiate that equation. If you differentiate y squared is px cube is plus q, we have 2y dy by dx is 3px squared, right? And substitute the point 2, 3 here. So what do I get? Dy by dx is equal to 3px squared upon 2y, and 3p x squared is 2 squared, so 2 into 2 by 2 into y is 3. So this cancels and we have 2p. So the slope is 2p and we know that that slope should be equal to 4. Therefore 2p should be equal to 4 and p should be 2. Now substitute p is equal to 2 in equation 1. That is 8p plus q is 9. 8p plus q is 9. Therefore 16 plus q is 9 and q is 9 minus 16, which is minus 7. Therefore p comma q is 2 comma minus 7. So the answer is 2 comma minus 7, option B. Very good. So the two equations, one, the point lies on the curve, and the second one, the slope of the line should be equal to the slope of the tangent to the curve at the point 2 comma 3. Solving them, we get P and Q. Let us go to question number 8. Another question based on the greatest integer function. The question is, the number of discontinuities of the greatest integer function f of x is equal to box x, where x is in this region, that is minus 3.5 to 100. Now there is nothing much to think about this problem. We know that box x is discontinuous at integer values of x. Integer values. So in this region, that is open interval minus 3.5 to 100, open interval 100, what are the integers that we have? Minus 3, minus 2, minus 1, 0, 1, 2, up to 99. 100 is excluded. Please note that. Therefore, how many do we have? 1, 2, 3, 4, and then another 99 numbers here. So 4 plus 99, we have a total of 103. 103 integer values in this domain, and therefore the number of discontinuities is 103. Be careful, don't include 100. That would give you 104 discontinuities, and there is an option like that. You're bound to make a mistake. Be careful of the open interval 100. Let us move on to question number 9. This is a question based on permutations and combinations. The number of ways of selecting 15 teams from 15 men and 15 women such that each team consists of a man and a woman is. Okay, now this question, many of you might think, okay, there are 15 factorial ways of arranging men and 15 factorial ways of arranging women. Therefore, the total answer is 15 factorial square, and since there is a 15 factorial square, jump at the answer, option C, but that is wrong. Why? Because if you think a little carefully, let's take the example of 2 men and 2 women. This logic should give us 2 factorial into 2 factorial, which is 4 ways. But if you have 2 men and 2 women, M1, woman 1, man 2 and woman 2, you have only 2 ways of doing this. M1, woman 1, a team, M2, woman 2, a team. Or M1, woman 2, a team, and M2, woman 1, another team. So there are 2 ways of forming 2 teams, which is only 2 factorial. The thing is, if you see that the point is only arranging the women is sufficient, or arranging the men, keeping the women same and arranging the men is sufficient, because 15 men, you arrange 15 men near 15 women, you get 15 teams. You need not move the women also. Moving the women will lead to repetitions when moving the men. Therefore, the idea I am trying to say is, you consider 15 men as 15 places, okay, man 1 till man 15, and in these 15 places you try to put the 15 women. So there are 15 ways of filling this place, 14 ways of filling this place, and so on up to one way, and therefore it is 15 factorial simple. It is not 15 factorial square, but only 15 factorial. So the option is B, 15 factorial. Tricky question. Going on to question number 10. If the general solution of the differential equation y dash is equal to y by x plus some function of x by y for some function phi is given by y ln mod cx is equal to x, where c is an arbitrary constant, then phi of 2 is equal to. So our task is to be able to find phi of 2, so we should know what is phi which is present in the differential equation, and we are given the solution. So let's go from the solution to the differential equation. Take the solution y ln mod cx is equal to x and differentiate this. So if I differentiate this, keeping y constant, differentiating ln cx, I get 1 by cx into c is equal to, plus, if I keep ln cx constant and differentiate y, I get dy by dx. This is equal to 1. Now how to eliminate dy by ln cx here, because the differential equation should not contain the arbitrary constant. This equation helps. Ln cx is x upon y. Substitute x upon y here. So I have y by x plus x upon y of dy by dx is equal to 1. Now a bit of rearranging and simplification. X upon y dy by dx is 1 minus y by x, and then multiply both sides by y by x, I get dy by dx, that is multiply the whole equation by y by x. So this becomes 1 is equal to y by x minus y by x, y squared by x squared, let us say. So now compare this with this. You can see that dy by dx is equal to y by x plus some function of x by y. So this is that function of x by y. So let us write that. The function of x by y is nothing but minus of y squared by x squared, or rather if I write it in this form, minus 1 by x by y the whole square. You can say that phi of x is nothing but minus 1 by x squared. Instead of the argument x by y, I am writing a simple x. Therefore, phi of 2 is minus 1 by 2 square, or minus 1 upon 4. So we have this in option B, minus 1 by 4. Alright, just eliminate the arbitrary constant by forming the differential equation and compare it with the given differential equation to get phi of x by y. And note that phi of x by y and phi of it's a y by x, so rewrite as an x by y term so that you can get a general expression. Phi of x is minus 1 by x squared. Moving on to question number 11. Sine inverse of 1 by 3 plus sine inverse of 2 by 3 is sine inverse of x, and then the value of x is how much? Okay, this again is a very direct question. If you remember that the identity sine inverse of A plus sine inverse of B is nothing but sine inverse of A into square root of 1 minus B square plus B into square root of 1 minus A squared, right? So therefore sine inverse of 1 by 3 plus sine inverse of 2 by 3 is nothing but sine inverse of A into 1 minus B square. So 1 by 3 times square root of 1 minus 1 by 4, right? 1 minus 4 by 9, excuse me. So we have 1 minus 4 by 9 plus B is 2 by 3 into square root of 1 minus 1 by 9. So this gives us sine inverse of 1 into, this is 9 minus 4 by 9, which is 5. So square root of 5 by square root of 9 is 3. So I have 3 into 3 plus 2 times. Here 9 minus 1 is 8. So 8 under root is 2 root 2 by 3, and this another 9 gives another 3. So this becomes sine inverse of root 5 plus 4 root 2 upon 9. Okay. So therefore, if this is equal to sine inverse of x as per the question, x is nothing but square root of 5 plus 4 into square root of 2 plus by 9. Option C. Very simple if you remember this expression, sine inverse of A plus sine inverse of B. Now remember, in exams like JEE main, the most important thing is the time in which you are able to solve these questions. Therefore, if this is the case, then remember these identities. The other procedure would be to remember a simpler identity, tan inverse of A plus tan inverse of B, which means you would have to convert both of these to tan inverses and then use this and then reconvert the answer back to sine inverse, which is going to be a little difficult. Remember, this identity helps you to do this problem very quickly. Going on to question number 12. This is a very direct problem. It says, if x and y are two distinct integers and n is a natural number, then x raised to n minus y raised to n is divisible by. Remember, x raised to n minus y raised to n is always divisible by x minus y. For example, x squared minus y squared, you know, is x minus y into x plus y. X cubed minus y cubed is x minus y into x squared plus xy plus y squared. The same way, x power n minus y power n is always divisible by x minus y. Therefore, the answer here is, when n is any natural number, this is true. Moving on. Question number 13. The area bounded by the curves y is equal to x minus 1 the whole square, y is equal to x plus 1 the whole square, and y is equal to 1 by 4 is. Now, the most important thing in these kind of problems is to be able to identify the area enclosed very quickly and then see if there are any symmetry, that is, this area is equal to that area, and all those considerations. So now y is equal to x minus 1 the whole square is a parabola open upward, vertex 1, 0, right? Therefore, if I draw this, if this is 1, 0, I have a parabola that is open upward, that will also pass through. At 0, it will be 1. So this point is 0, 1. Okay. Now the same way, the parabola y is equal to x plus 1 the whole square is also open upward, vertex at minus 1, 0. So now that parabola is going to be here, minus 1, 0. And you should be able to see that it passes through this point also, 0, 1. Substitute 0, x is 0, you get y is 1. And then we have finally the third factor, which is the line y is equal to 1 by 4, is simply a horizontal line parallel to the x-axis. So the area we need is this area here. Alright, so this is y is 1 by 4. Okay, how to proceed? Now first of all, we need the boundaries for x. Second of all, you see that this area is equal to this area because the two parabolas are symmetric. It is basically y is equal to x squared, just shifted a little to this side and I shifted a little to this side. Okay, so shifted by the same amount, see? Okay. Now, since both areas are the same, it's sufficient to find only one area and then multiply by 2. But still, let us find these limits. That is, where will y is equal to 1 by 4 intersect these curves? So put y is 1 by 4 here. 1 by 4 is x minus 1 the whole square, or x minus 1 is plus or minus 1 by 2, which gives x is 1 by 2 or 3 by 2, right? So this is that 1 by 2 point, and this would be 3 by 2. It would intersect again at 3 by 2. The same way, this would be x is minus 1 by 2, and there will be an x is minus 3 by 2 point here. So we have the limits and we have the area. Next step is to integrate and find the answer. So let us draw that region alone a little here for the sake of clarity. We have this parabola, we have another parabola, and we have this line. So we are looking at this area. So this is y is x minus 1 the whole square. This is y is x plus 1 the whole square. And we have y is equal to 1 by 4 here. Now let's see. These limits also are known. So the area 1 and area 2. Area 1 is going to be integral minus 1 by 2 and 1 by 2. Minus 1 by 2 to 0. The parabola minus the line dx, right? And same way, the area 2 would be 1 by 2 to 0, the parabola minus 1 by 4 dx. Now I told you that these two areas are symmetric, so I'll do only one. I encourage you to try this also and show that these two areas are equal. I would solve this and multiply the answer by 2 to get the area. So let us solve this one. So integral x minus 1 the whole square is x minus, I am finding only area 2, x minus 1 the whole cube by 3 minus x by 4 from 0 to 1, or sorry, this limits, there has been a mistake, it has to be 0 to 1 by 2. So 0 to 1 by 2. So substitute the upper limit. I get minus 1 by 2 the whole cube by 3 minus 1 by 2 by 4 minus of, and the lower limit gives minus 1 the whole cube by 3 minus 0. Therefore I get minus 1 by 8 by 3, which is minus 1 by 24, and here I get a minus 1 by 8, and here I get a nice plus 1 by 3. The LCM being 24, minus 1 minus 3 plus 8, or 4 upon 24, which is 1 upon 6. Therefore the total area is 2 times the area of 2, which is 2 times 1 by 6, or 1 upon 3. Please check that this integral will also evaluate to 1 upon 6. So the answer is 1 upon 3 square units, option A. Alright. So what we did quickly, the first parabola is an open up parabola, vertex 1, 0. The second parabola is an open up parabola, minus 1, 0. And both are symmetric to each other. Both pass through this point 0, 1. And both are intersected by y is equal to 1 by 4 at equal distances from the y-axis. At y-axis minus 1 by 2 and x is equal to 1 by 2. Using arguments of symmetry, evaluate either one of these integrals and multiply by 2. You get the answer. Moving on to question number 14. The number of roots of the equation cos squared x plus square root of 3 plus 1 by 2 sin x minus square root of 3 by 4 minus 1 is equal to 0, which lie in the interval minus pi to pi s. Now this equation seems a bit intimidating, a scary equation, but it's very simple if we consider cos squared x. I'm going to substitute it with sin squared x and make it a quadratic equation in sin x. So this is 1 minus sin squared x plus square root of 3 plus 1 upon 2 sin x minus square root of 3 upon 4 minus 1 is 0, right? Now this results in this 1 and minus 1 cancelling each other, and then multiply the whole thing by a negative sign. I get sin squared x minus of root 3 plus 1 by 2 sin x, and then minus plus root 3 upon 4 is 0. Okay. Now this can easily be factorized if you see that this is root 3 plus 1 by 2 and this is nothing but root 3 by 2 into 1 by 2. This is root 3 by 2 plus 1 by 2 with a minus. Therefore the two roots can be easily written like this. Sin x minus root 3 by 2 times sin x minus 1 by 2 is 0. Understood? The sum of these two should be minus root 3 plus 1 by 2 and the product of those two should be root 3 by 4. So this would give me sin x is root 3 by 2 and sin x is 1 by 2. Now using these, let us determine how many solutions we have in this given interval. So the interval given is minus pi to pi. Now we have sin x is root 3 by 2, let us say. Now we know that the principal argument of the solution x will be pi by 3, right? Sin pi by 3 is root 3 by 2. Now at the same time there is also an angle in the second quadrant 2 pi by 3 because sin pi minus pi by 3 is also equal to sin pi by 3, right? Therefore 2 pi by 3 is also a solution. The same way sin x 1 by 2 gives x is pi by 6 and then pi minus pi by 6 which is 5 pi by 6. Since sin of pi minus pi by 6 is sin pi by 6. These are another two solutions. There are no solutions in the negative part because sin is not negative in the fourth quadrant. Therefore, the four solutions are pi by 6, pi by 3, 2 pi by 3 and 5 pi by 6. So the number of solutions is 4 and the answer is option number B, 4, right? A bit tricky question, just convert it into a quadratic in sin x, and if you notice that these two are the sum and product of minus root 3 by 2 and minus 1 by 2, easy factorization, and then you get known values of sin x which are root 3 by 2 and 1 by 2. Alright, let us move on to question number 15. A question based on the properties of triangles. Suppose that the side lengths of a triangle are 3 consecutive integers and one of the angles is twice another. Number of such triangles is R. Now, according to me, in this whole paper, NTA's first paper, the most difficult problem would be this. And this you can consider a JEE advanced level problem also. Okay, let us picture this triangle. How would this triangle be? It is a triangle whose sides are 3 consecutive integers that we do not know. So let us leave it for that for the moment. Let us just say that there is a triangle ABC, and the standard procedure we know that this is side A, this is side B and this is side C. And let us say this angle is alpha and this angle is 2 alpha because they have given us that one of the angles is twice the other. So this angle A is twice angle C. So right here let me make one observation based on what we have drawn. Since angle A is greater than angle C, side A will be greater than side C. The greater angle has the greater side opposite to it, right? Keep this in mind. This would be used at a later point. Okay. Now in this condition, how do we proceed? The first thing is to get an equation between A, B and C for such a triangle where alpha and the other angle is 2 alpha. How can we go about it? We make a construction. Draw the angle bisector or of angle A. Let us say AD is the angle bisector of angle A. Therefore, this angle would be alpha and this angle also would be alpha. Alright? So what we have is ADC is an isosceles triangle, 2 angles are equal. And then we have another angle, here this alpha. What would this angle be? This angle is nothing but is the exterior angle of this triangle ADC. So it is equal to the sum of interior opposite angles. So this will also be 2 alpha. Alright. So first things first, let us try to find BD and DC. We know according to angle bisector theorem, the angle bisector divides the side according to the ratio of the corresponding sides. That is, BD upon CD would be equal to AB upon AC, right? That is, BD can be written as AB is nothing but C and AC is nothing but B times CD. Together with this, we know BD plus CD should be equal to A. So using these two equations, substitute 1 in 2, you get C by B into CD plus CD is equal to A, or CD into C plus B by B is equal to A, or CD is AB by B plus C. Alright? The same way, you know from this equation BD is C by B of this, and that would give BD is C by B of AB by B plus C, or AC upon B plus C. So this is AC upon B plus C, and this is AB upon B plus C. So you see A is divided in the ratio C is to B basically, right? Angle bisector theorem. Good. Now this is the first part. The second part is to observe that there are similar triangles here. How come? If you consider triangle ABC, two of its angles are alpha and 2 alpha, right? That is the main consideration we made. Now if you consider triangle ABD, angle A is alpha in that triangle and angle D is 2 alpha. So there are two triangles with two angles equal, and such triangles are called similar triangles, of course. Therefore, let us draw these two similar triangles. One triangle is nothing but the triangle that we started with, ABC, alpha here and 2 alpha here, and the sides are A, B and C. Now the other triangle that I am saying is similar to this is ABD, because it has alpha here and it has 2 alpha here, and its sides are, this is nothing but C, and this we have found is AC by B plus C, right? And this side, if you want, is nothing but AB by B plus C. How so? Because we said that this triangle is an isosceles triangle because there are two angles alpha, so this side CD should be equal to AD. If you want, AD is also this value. Alright, so from this similar triangles, let us write a relationship between A, B and C. Okay, so if I write the property of proportionality of the sides, right, the sides are proportional. Consider this side AB and BD of this triangle. That is, I am going to write AB, these two are similar to each other. Okay, so AB by BD in triangle ABD. Now AB in this triangle is the line between the third angle, which actually is 180 minus 3 alpha. No magic there. So this angle is at 180 minus 3 alpha. So AB is 180 minus is the line connecting 180 minus 3 alpha and the alpha angle, which here is this side. So BC. And the same way, BD is the line connecting 180 minus 3 alpha and 2 alpha, which is this side, which is nothing but AB. So write the similarity properly, so that will give you that required equation. So AB by BC, what would this be? AB in this triangle is C, divided by BC is nothing but, AB by BD in that triangle is what we are writing. AB by BD. Okay. AB by BD will be equal to BC by AB. Okay. So AB is C, and therefore BD is AC by B plus C. This should be equal to BC in this triangle is A and AB in this triangle is C. Alright. So this C and C can be cancelled here. So this would give us B plus C by A is equal to A by C, or A squared is equal to C into C plus B. Now this is the relation with which we will be working now. Okay. Now we got A squared is equal to C into C plus B. And remember, in the very beginning I told that A is greater than C, right? A is greater than C because A is opposite to 2 alpha and C is opposite to alpha. So if we consider that the three sides are C, C plus 1, C plus 2, for example, then A can be equal to C plus 1 or C plus 2, right? It has to be 1 greater or 2 greater than C. Now let us consider both these cases and see what we have. If I say A is equal to C plus 1, then this would imply that B has to be the other C plus 2, right? And C is C. Substitute these three in equation 1. So A squared C plus 1 the whole squared is equal to C into C plus B. C plus B is C plus 2. Now this would give me C squared plus 2C plus 1 is equal to 2C squared plus 2C. Cancel these and you get C squared is 1, C is 1. Minus 1 is not possible because it's the sides of triangles. Therefore A will be is equal to 2 and B will be equal to 3. However, A2, B3 and C1 is not a triangle, it's just a straight line with different line segments, right? This is C, this is A, and the whole thing should be B3. So no triangle here. Let us try A is C plus 2, in which case B will be C plus 1, right? Now this would give us C plus 2 the whole square, substituting in the same equation in 1. C plus 2 the whole square is C into C plus 1. Now this would give C squared plus 4C plus 4 is 2C squared plus C, or rewriting C squared minus 3C minus 4 is 0, or C minus 4 into C plus 1 is 0, which implies C is equal to 4 or minus 1. So C is 4, let us say, would imply A is C plus 2, therefore 5, and B is C plus 1, sorry, C plus 2 is 6, B is C plus 1, 5. So A6, B5 and C4 is one triangle which satisfies both these conditions. So very intricate problem. Let's go through the solution once quickly. The first construction is to make this angle bisector and to find these two sides, these two segments of the line BC, right? And that gave us BC is equal to AC by B plus C and CD is equal to AB by B plus C. The next step was to consider that these two triangles are similar and take that in this triangle AB by BD should in this triangle be BC by AB. You see the sides joining the corresponding angles, as simple as that. And substituting the values, you get this magic equation that we need. A squared is C into C plus B. And then using the consideration, A should be greater than C. A can be C plus 1 or C plus 2. A is C plus 1 cases here, A is C plus 2 cases here. Okay, a very nice question, not very difficult, but to get these ideas in succession is challenging. But JEE means supposed to be like that. So the answer is there is only one triangle which satisfies this. So option A, only one triangle. Moving on to question number 16. Now, after a difficult problem comes a quite simple problem. If x is 33 raised to n, where n is a positive integral value, then the probability that x will have 3 at its units place. These are very simple problems. If you recognize one aspect, that is the product of any two numbers, let us say, let us say 456 multiplied by 738, the units place is going to be the units place of the product of these two units place numbers. That is 6 8s are 48. Therefore, the units place will have 8 only. It's as simple as that. So, same way, you take 33 raised to 1, the units place is 3. Now, 32 raised to 2 is nothing but 33 into 33, and the units place will be some number 9. 3 3s are 9. Now, 33 cube will be some number ending with 9 into 33, right? Because 33 square you said ends with 9. So this would be a number ending with 7. So same way 33 power 4 would end with 1. 33 power 5 would end with 3 again. 33 power 6 would end with 9. So you see this 3 9 7 1 will start repeating here. Alright. So only 4 possible numbers can come at the units place of 33 raised to n. Those are 3, 9, 7 and 1. Of this, the probability that it should be 3 is 1 out of 4. Very simple. Try this for any number. You try for maybe, for example, let us say 32 raised to n. The last numbers would be 2, 4, 8, 6 and then again 2, 4, 8, 6. So only 2, 4, 8 and 6 would be allowed in the last place. Alright, and using this you can say that the probability of having any one would be 1 by 4. Alright, moving on to question number 17. If y is given by log x base 10 plus log 10 base x plus log x base x plus log 10 base 10, then dy by dx. Differentiation. Now we all know that log of x, when it is differentiated, gives us 1 by x. But this means that log has base e, not log base 10 or log base x as in these cases. So the first thing is to convert these to log base 10, log base e, excuse me. How do we do that? We know log a base b can be written as log a base c upon log b base c, right? Therefore, y, this log x base 10 can be written as log x base e upon log 10 base e plus the second term will become log 10 base e upon log x base e. Now the third term is 1 and the fourth term is also 1, right? This can be differentiated now. Now the first term is some constant into log x, right? So it will be that constant which cannot be differentiated into log of x is 1 by x. And then here what happens? The constant is in the numerator and this is 1 by log x. 1 by log x is of the form 1 by x. So you know that the differentiation is minus 1 by log x the whole square. And again, if you differentiate log x, you get 1 by x. Therefore, and these two constants when differentiating, they vanish. So dy by dx can be written in a neat form as 1 by x log 10 base e minus log 10 base e by x times log of x base e the whole square. So this is option A, 1 by x log 10 base c. Yeah. So this is option A. Very simple, just remember to change the base to e. Question 18. Z is a complex number that satisfies the condition mod z is greater than or equal to 3. Then the least value of z plus 1 by z is how much? Now all these problems which involve minimum values, maximum values are based usually on the triangle inequalities. The first one is mod z1 plus z2 is always less than or equal to mod z1 plus mod z2. Use this whenever you need maximum values for Z1 plus Z2 and the like. The second one is mod Z1 minus Z2 is always greater than or equal to mod Z1 minus mod Z2 within the whole mod. Now use this whenever you need the minimum values, and since the question is least, we will try to make use of this. How can we rewrite Z plus 1 by Z in a minus form? Very simple, Z minus 1 by Z. This should always be greater than mod of mod Z minus mod of 1 by Z, the whole mod, right? Now mod of minus 1 by Z is 1 by mod Z, because mod of minus 1 is 1 and mod Z is Z. And since mod Z is going to be greater than or equal to 3, this first term is going to be greater than the second term. Alright? So what we have so far is mod Z plus 1 by Z is greater than or equal to mod Z minus 1 by mod Z. I am dropping the mod on the outside because Z is 3 will always be greater than 1 by Z for this condition. Alright. So the minimum value will be when this Z takes the minimum value. So this is mod Z plus 1 by Z would be greater than or equal to 3 minus 1 by 3, which is 8 by 3. So mod Z plus 1 by Z is greater than or equal to 8 by 3. Therefore you see that the minimum value is 8 upon 3. So the answer is option C, 8 upon 3. Very simple. Use the triangle inequalities. Just reorganize to a negative form so that you get this. Question number 19. If A, B, C, D, E, F are in arithmetic progression, then E minus C is equal to. E minus C is 2 times the common difference, right? Because between any consecutive numbers, the difference is one common difference, D. So C to D there is one common difference, and D to E another common difference. Now this twice common difference, if you see here, 2 times C minus A is in itself 2 times common difference. So 2 times common difference, which is 4 times common difference. Now 2 times D minus C we know is common difference, so this is 2 times common difference. 2 times F minus D is 2 times common difference, so 2 into 2 times common difference. Finally D minus C is common difference. So therefore this is 4 times common difference, this is 2 times common difference, 4 times and 1 time common difference. Since we need 2 times common difference, the answer is option B, 2 times D minus C. The last single choice question is an indefinite integral problem. Integral ln of x plus 1 minus ln x by x into x plus 1. Seems scary in the beginning, but then it is simple. If you identify that this x plus 1 is here and this x is also here, this gives us some hint. Take the numerator as t. Then what would be dt? It would be 1 by x plus 1 minus 1 by x. Simplify this a little bit, taking the LCM, x into x plus 1, into dx. So x minus of x plus 1. So this would give me dt is minus 1 upon x into x plus 1 dx, or this whole thing is minus dt. So you see that dx upon x into x plus 1 is minus dt. So if the numerator is t, then the rest is minus dt. So the integral becomes t minus dt, which is minus of t dt. This is nothing but minus of t squared by 2 plus c. Right? Let us substitute the value of t. T is ln of x plus 1 minus ln of x, the whole square, with a minus by 2 plus c. Now this is simple. Ln a minus ln b is ln of a by b, the whole square, by 2 plus c. So this is the final answer. Minus ln x plus 1 by x the whole square upon 2 plus c. and this is option A, minus 1 by 2 ln of x plus 1 by x the whole square plus c. Very simple, take the numerator as t and the rest is dt. Now the next 5 questions will be based on a subjective analysis. They are not objective anymore. The first question, f of x is a polynomial, very important. A polynomial is of the form ax power n plus bx power n minus 1 and so on, an nth degree polynomial. And it satisfies the condition f of x into f of x 1 by x is equal to f of x plus 1 by x. And f of 2 is greater than 1. The limit of f of x when x tends to 1 is. Tricky problem. Let's see how to go about it. The first thing is we have f of x into f of 1 by x minus f of x minus f of 1 by x is equal to 0, right? Let us just consider, add 1 to both sides. So what happens? F of x into f of 1 by x. If I take f of x common from both, I get minus 1 already here, and then imagine I have minus 1 and I am adding plus 1 to both sides. Now this should give me f of x. Here also I have f of 1 by x minus 1 minus f of 1 by x minus 1 is 1. Or if I take f of 1 by x minus 1 common between these two terms, I get f of x minus 1. Now let us say that f of x minus 1 is some g of x. Therefore, f of 1 by x minus 1 would be g of 1 by x. And since f of x is a polynomial, g of x also is a polynomial, right? Therefore, this equation becomes g of 1 by x into g of x is equal to 1. That is a polynomial into the polynomial 1 by x is 1. Now this can happen only if that polynomial g of x is of the form x power n plus or minus, right? Only then g of 1 by x would be 1 by x power n plus or minus, and when you multiply both this you will get 1. No other polynomial will have this form. If there is another term x power n plus x, then the 1 by x will be 1 by x power n plus 1 by x, which will not be the reciprocal of this, and this condition will be violated. Therefore g of x should be of this form, and therefore f of x, which is g of x plus 1, should be of the form plus x power n plus 1 or minus x power n plus 1, right? Now use this condition, f of 2 should be greater than 1. If f of 2 should be greater than 1 for any n here, then you can't have this condition, because this would make it less than 0, a negative value, right? Let us say n is 2, then minus 2 squared, my plus 1 is minus 3. So f of 2 cannot be greater than 1. Therefore, this will always result in f of 2 greater than 1. So, f of x is x raised to n plus 1. Once you know this, limit x tends to 1 of f of x is 1 raised to n plus 1, which is 2. So the answer to this problem is 2. Very simple, but it depends that you guess this combination. You add 1 and bring it to this form, that the function into 1 by x is 1, and come to this. Let us move on to question number 22. If A is equal to a matrix 1 0 0 0 1 1 0 minus 2 4 and I is 1 0 0, the usual identity matrix, and A inverse is equal to 1 by 6 A squared plus 6 plus CA plus D. Let me point out one small mistake here. This has to be DI. okay, because you can't add a scalar and a matrix. That's di. Then the sum of values of c and d, that is c plus d, is how much? Now the direct method is find the inverse and then substitute the a squared here and a here and I here and get equations for c and d and then solve them, right? Now, how can we do this quickly? If you see that this first element that in this whole problem, if you observe carefully, c plus d, when you multiply c into a, you get a c here, and when you multiply d into I, you get a d here. So c plus d would be here, right? And a squared. So if you look only at the first elements of all these matrices, the first element of A inverse, first element of A squared, first element of A and first element of DI, that is sufficient to give what will be the value of C plus D. You did not do the whole matrix. Do you understand what I am saying? That is, find A squared. A squared would be 1 0 0 0 1 1 0 minus 2 4 and 1 0 0 0 1 1 0 minus 2 4. All I am telling you is just find the first element 1 1. So that will be 1. And all the elements you can evaluate. This would turn out to be 0 0 0 0 and some other numbers here. We will not bother about all those elements. All we need is this one element. What about A inverse? A inverse we know is the determinant, 1 by determinant A into adjoint of A. Now again I am going to look only for the topmost element. I am not going to worry about all these elements. Only this element I need. How to do that? 1 by determinant of A is nothing but 1 by, the determinant of this matrix is fairly simple. 1 into 1 into 4. So 1 into 4 minus 2, which is 6. And if you see the element that comes here is nothing but the cofactor of this 1, right? The cofactor of the 1 will be 4 minus 1 minus 2, which is 6 again. And all the other elements, let us not bother. So this is a 1 by 6 into 6 and followed by other elements and etc. So I get A inverse is 1 and then some other numbers everywhere. Okay. So substitute these in this equation. A inverse is 1 and then I don't know what these are going to be, although I can guess that these two are going to be zeros as well. This is that matrix of A inverse is 1 by 6. A squared we saw is just 1 again here and all these are unknown, plus C into A is also 1 0 0 0 1 1 0 minus 2 4 and D is nothing but 1 0 0 0 1 0 0 0 1, right? Now look only at the first elements. So I get 1 is equal to, here it is nothing but 1 by 6 of, the first element is 1, the first element here is 6, C, and the first element here is D. So this becomes 6 is 1 plus C plus D, or C plus D is 5. I didn't have to evaluate the whole matrix, the whole inverse, the whole square, nothing. I can do the whole thing because of this particular structure of this matrix. This is also 1 0 0 form, this is also the form 1 0 0. So the square also will be of the form 1 0 0 and this would give me already C plus D here. And A inverse also turns out to be 1 and something and something. So the trick was to find only the first element of all these matrices. The first element of A inverse is 1, first element of A squared is also 1, first element of C into A is C, first element of D into I is D, and from here I get C plus D is equal to 5. So the answer for this question is 5. Okay. So look at the matrix and get the idea. Now there is also another technique based on another theorem which you don't learn in class 12 called the Cayley-Hamilton theorem. This I'll just mention this for the sake of presenting an alternate method which you can try for a little more complicated matrices. So here you have A is 1 0 0 0 0 1 1 and minus 2 and 4. Alright. Now this Cayley-Hamilton theorem says that you form an equation of this matrix with a minus x along all the diagonal elements and leave the rest of the elements unchanged, and put the determinant of this. So this is nothing but, this is not a as such. You transform that a into this form with a minus and all. Basically it is a minus x times I. Now you find the determinant of this matrix, which would be 1 minus x into 1 minus x, 4 minus x plus 2, and you expand this carefully. So there is 1 minus x into 4, and then I have plus x squared, and then minus 5x plus 2 makes it 6. So this becomes 6 plus x squared minus 5x minus 6x minus x cubed plus 5x squared. Okay, so this equation is minus x cubed plus 6x squared minus 11x and 6, and put that this determinant to be equal to 0. Now Cayley-Hamilton theorem says, Cayley-Hamilton theorem says that the matrix satisfies this equation. This equation, if I multiply it by a negative sign, I get x cubed minus 6x squared plus 11x minus 6 is 0. The matrix itself satisfies this equation, that is a cubed minus 6a squared plus 11a minus 6i is 0. This is the theorem. This can be used to find A inverse also. If you multiply the whole equation by A inverse, you get a squared minus 6a plus 11i minus 6a inverse is 0. This would give you a squared minus 6a plus 11i by 6 is equal to a inverse. Take this term there and bring that 6 here. Now compare this and the equation given for us. A inverse is 1 by 6. Our equation was 1 by 6 a squared plus ca plus di. This also gives you c is minus 6 and d is 11. C plus d would be 5. This is another way of doing it. I prefer doing it the normal way for the special matrices. Find only the first element, because you get already c plus d. C into a will give you c and d into I will give you d. So c plus d comes from here, and find the first elements of these two. You are settled, right? Very good. Let us move on to question number 23. The least value of the quadratic polynomial, and they have given a quadratic polynomial for real values of p and x. So considering all values of p and x, what would be the least value for this polynomial? How to go about this? Make it squares, right? What do I mean? Collect all the p squared terms. So if I take 2p squared common, I have an x squared here, and from here this is 8p squared x. So if I take 2p squared common, I have plus 4x, and from here if I take 2p squared common, I get plus 4. And then there are other terms, which is x squared, and here minus 2x and a plus 4, right? So this is 2p squared, and if you see that this bracket term x squared plus 4x plus 4 is nothing but x plus 2 the whole square, and then this 4 if I separate as 1 plus 3, x squared minus 2x plus 1 is x minus 1 the whole square plus 3. Now you have a squared term plus another squared term plus 3. These are all always positive, right? Therefore the minimum value of this function can only be 3. And that would occur when both these terms are 0. This is 0 and this is 0. Now this is 0 implies x is equal to 1. So this won't be 0. So this term to become 0, p has to become 0. So when p is 0 and x is 1, the function f of x will take 3, which is the minimum value for this quadratic polynomial. Alright, so f of x is equal to 3 is the answer. Moving to the last but one problem. A, B, C are in arithmetic progression and B is pi by 4, then tan A, tan B, tan C is. So this is pi by 4. So A should be pi by 4 minus D and C should be pi by 4 plus D. Therefore already we see A plus C is pi by 2, right? Or A can be written as pi by 2 minus C. So tan A, tan B, tan C is nothing but tan pi by 2 minus C, tan pi by 4 and tan C, because B is pi by 4 and A is pi by 2 minus C. Tan pi by 2 minus C is cot C, tan pi by 4 is 1 and tan C is tan C. Now this is nothing but 1 by tan C into 1 into tan C, which is 1. So the answer to this question is 1. The last problem of the first paper. The distance of the point minus 1 comma 1 from the line 12 times x plus 6 is equal to 5 times y minus 2 is. Now we know the distance of the point x1 comma y1 from a line ax plus by plus c is equal to 0 is given by modulus of ax1 plus by1 plus c upon square root of a square plus b square. So let's rewrite the equation of the line in this form. It is 12x plus 72 is 5y minus 10. So 12x minus 5y is plus 82 is 0. Now the point given is minus 1 comma 1. So the distance using this formula is mod of 12 into minus 1 minus 5 into 1 plus 82 upon square root of 12 square plus 5 square. So this becomes 65 upon 13, which is 5 units. So the answer is 5 units. This brings us to the conclusion of the mathematics part of the first paper. I hope you understood the solutions quite clearly. Practice them again, and I promise to see you again with NTA test paper 2, the mathematics part. This is SANTOSHSIR from Parth Tank Mathematics Institute, Ahmedabad.